end of the day. Last talk. Let's see if we can end it on a high. It was a great venue. Loved being here. Loved seeing you all. And it felt very cozy. This was a very cozy conference. I really, really enjoyed it. It made me feel part of the group. The agenda for this talk is on this slide. So I'll talk a little bit about my portable Homelab and how I bootstrap it. I will talk about that arrow, how do you go from Homelab to production, and then we'll end up with some takeaways that I've learned over the years, my personal takeaways that served me well, and I think they will serve you well too. So this talk began shipit.show 84, bare metal meets Talos Linux. It was December 2022 when this talk began. And if you were to scroll down past the show notes, what you would see on the left-hand side is a super micro motherboard mounted on an open bench that's covering my face. That was my first Homelab running Talos Linux. Almost 2 years later, and 366 commits, I have gone through more than a dozen Talos clusters, both in my Homelab and in production. And after everything that I've learned, all the experiments, I'd like to show you how I would ship a Homelab into production. First, a question to you. There are two things wrong in this picture. Who can spot the first thing wrong? Any ideas? Yes.
There's no power.
There's no power. Yes. Okay. Three things wrong. Yes. No network. Yes. Yes, indeed. Let's assume that we had powered network. Yes. NVMe draws too much power. Close. No. However, this particular NVMe is not compatible with Raspberry Pi 5. I learned the hard way, okay? So don't get that NVMe, it will not work. The other thing which is wrong is that currently, Talos Linux is not supported on Raspberry Pi 5. Next year, there will be an LTS kernel, and there will be U-boot support for Talos Linux. So next year, we assume that this will work. So we're going to leave the Raspberry Pi 5 there just for comparison, right, to see what it looks like. We will be focusing on the device underneath. It's a LattePanga Sigma. It's significantly more powerful than the Raspberry Pi 5. It has, as you can see on the left-hand side, that's a wireless Intel Wi-Fi 6, two 4 terabyte NVMe drives. You can see here two 2.5 gigabit Ethernet ports, some wireless antennas, which are very handy. And underneath this massive heatsink, which has a fan, there's the 12-core i5 and 32 gigs of DDR5. So I have this device here with me today. It's running. It's working. Why is it not connecting to Omni? What's missing? Correct. So yes, exactly. So Talos does not have wireless drivers for network cards. So as a Homelabber that I am, I not only bring my portable Homelab, you also need to have a router which has dual radio, so it's able to connect to the Wi-Fi. And then, very simple device. Look at this. This is, I think, one of the most satisfying sounds, I think, to me. Not sure if you heard it. No? No? Almost. Close enough. So that's satisfying. Once we do that, it will connect to Omni. So what do we see? I think most of you have used Omni, right? Or at least know about Omni. To me, Omni is a great way to see what machines I have. Doesn't matter where they are. Everything registers. I can visualize them. It's a very nice UI to see what I have running. Doesn't matter which provider I'm running it on. Doesn't matter whether it's in my Homelab. It doesn't matter where it is. It's a VM, bare metal. Everything shows up here, and it makes it very easy to click through things, understand what I have running, what's going on. We have the machine connected. We have it running Talos. So how would I bootstrap it? Everything for me starts with a cluster manifest, and I think for many of you as well. And it's a cluster manifest that Omni understands. In this case, I'm saying the name of the cluster is Homelab 2024-0918, and it has everything it needs for this cluster. So I can see the Talos version, the Kubernetes version. I have some backup configured. I mean, it's right there how often they should back up. I have a bunch of patches applied, very simple, and I have a single node, which is control plane, and I'm allow scheduling on control planes. Once I have this, bootstrapping a node will take me 20 seconds. Let's go. So I'm just going to run the bootstrap command. It doesn't matter what it spits out. In the background, basically, it runs 3 commands. It validates the manifest, it applies the manifest, and then it configures backups. 3 commands, 3 omnictl commands, and off it goes. And now the cluster, which is a single node cluster, is being bootstrapped. Once that's done, the next thing that I do, I install Argo CD. And the reason why I install Argo CD, there you go, there's a secret, 1Password CLI, so that it gets the secret for the repository. Argo CD will manage everything else that runs on this node. So it's self-contained, which means that Omni bootstrap, next command, as soon as you're finished bootstrapping and the node is healthy, apply my Argo CD, and Argo CD will manage everything else. A simple, single, self-contained node. So what is running on this Homelab? This is a list of all the things that I have running, things that I find very useful. For example, Cloud Native PG. It's an operator for provisioning Postgres clusters, which has backups, which has a bunch of things which make it really useful to bootstrap Postgres clusters from backups, for example. CSI driver LVM. I like my LVM. I'm very glad that it's so easy to use it. An operating and slice a disk, you can make use of those local NVMe disks, and everything's local. Dagger, we'll come back to that. Ingress Nginx, you already know. Keel.sh, it's something which I find is a very easy way to update applications running on the cluster without forcing you through the whole GitOps flow. There are certain moments when you do want to go through GitOps, but others when you don't. Keel helps with that. Kubernetes stack, right, for all the monitoring, and Tailscale. Tailscale, again, is the operator, which means that any service that I install on the cluster, I can say, hey, make it available on my Tailscale network, which means that I can connect to it from every single device on my Tailnet. Whether it's my phone, whether it's my laptop, whether it's my desktop, doesn't matter where I am. As long as it's on the Tailnet, it can connect to any service running in this Homelab, regardless where I am. Super powerful. All right. So the most important thing that's running on this node is an application called Daggerverse. Daggerverse is a Go application. It has 2 web instances in this case, and it needs Postgres for data. All this data is stored in Postgres, and there you can see we can have by default 3 Postgres nodes. You may be thinking, why 3? It's just a single node. It's a default, right? So I just went with the default. There's 2 readers and 1 writer. We can see a similar view for the services, and this is K9's CLI. I think many of you have used it. It's very useful if you like Vim, if you like Ncurses interfaces, it makes jumping around very, very easy. What we're looking at here is a Daggerverse web Tailnet service, which is of type load balancer. And because it's a Tailscale provisioned and managed service, we can see that it will appear on my Tailnet, and you can see the external IP. There's a DNS, right? So Daggerverse, the name of the cluster, and then tail ts.net, which means that any host on my Tailnet can connect to this specific service. So that's what we're going to do now. Daggerverse Homelab, because the search domain is my DNS, I'm using Magic DNS, boom. This is the Daggerverse running locally. So what is Daggerverse? Daggerverse is an application, it's a Go-based application, which has modules. You can think of them like GitHub Actions from the marketplace, right, when you're using your pipelines. But it's open source, it's community-driven, and it allows you to very quickly build automation. You can reuse components. And we'll come back to that later. All right. Speaking of Tailnet and Tailscale and all of that, has anyone seen this article or read this article, The New Internet? Okay, it's the best article I've read all year. It's worth your time. It's on the Tailscale blog, The New Internet. And there's this specific paragraph which I wanted to highlight. I read a post recently where someone bragged about using Kubernetes to scale all the way up to 500,000 page views per month. But that's 0.2 requests per second. I could serve that from my phone on battery power, and it would spend most of its time asleep. So what do you think? How many requests per second can this LattePanga Sigma serve? Who thinks it's A? Hands up. No one. B, C, okay, there's a few C's, and D, 10,000. Cool, okay, so everyone thinks it's C, cool. All right, so when I did this benchmark, I did it over a 10 gigabit network. The host on the left-hand side had a 10 gig full uplink, and there was a switch in between, and the LattePanga Sigma, I already mentioned, 2.5 gigs. I'm using OHA here. Anyone has seen OHA, has used OHA? Okay, it's an ncurses, again, ncurses, that's a theme. It's an ncurses HTTP benchmarking tool. It's written in Rust, it's very performant. And what I'm doing here, I'm running a test for 10 seconds, and I'm hitting directly the service on the Tailnet. So here it goes. This is what it looks like when you run it. 5 seconds, almost there. We can see the histogram on the right-hand side, requests per second. So this is what it looks like when we benchmark the application, the Go app directly. 75 requests per second. And the latency doesn't look so good. So what's going on here? Well, there's a pod which I have running, sysadmin, btop, running the same requests, and I'm looking at the node. And this is what I see. The CPU, 100% utilization. What else do we see on the right-hand side? We can see the two commands, the Daggerverse commands, the binary, 23, 22% CPU, and you can see a lot of Postgres threads. So without knowing much about the application, I can tell that there's a lot of communication with the database, and that's a bit slow. Okay. This is a sysadmin trick, okay? Without knowing anything, one-liner, how can I make this thing fast? Ingress Nginx. I have a microcache, a 30-second microcache, and I'm telling it any GET request, just use the microcache. For 30 seconds, serve it from Nginx. When we do that, this is what we see. Now I'm going to Nginx now, and this is the result. Same 10-second test, real time. It's doing a lot better. You can see the latency, it's a lot better as well. And we get 5,000 requests per second, 2.7 gigabytes. The latency is much better. We're just basically benchmarking Nginx. Cool. So the answer was B. That was the correct answer. There's a physical bottleneck in our LattePanga Sigma. Who can spot it? There's a bottleneck that won't allow us to go past 5,000 requests per second. Why is that? It's on this page.
It's the network.
Correct. It's the networking, yes. 2.29 gigabits, bottom left corner. We're maxing out the network at this point. The application, right, is like doing its job, Nginx is doing its job, we're saturating the network. So that's what's happening here. Okay, we want to confirm that that is indeed what's happening. Okay, we have iPerf3 running, and I have iPerf3 running on the benchmarking machine. I can confirm that that is the top speed at TCP that this LattePanga Sigma can serve. So I've confirmed that indeed it is networking, and I can do a reverse one as well. It is the network, and this confirms it. Cool. Can we squeeze more requests per second? And the answer is yes. If we were to, as you can see, I'm using OHA, same thing as before. I'm going directly to the Go application. I'm serving a static file, which is the X logo, the XSVG. It's about 500 bytes, so very small. And we can see that I can push about 120,000 requests per second. Based on what you're benchmarking, it can do more, it can do less, different bottlenecks in your stack. You may be thinking, well, you only ran it for maybe, I don't know, a minute or two. Actually, I served 100 million requests. I let it run for about 14 minutes. And you can see at the top left, right, Grafana, Kubernetes stack, directly running on the node. We can see that the CPU is almost 100% utilized. We can see the load average, right? It goes beyond 16. We can see the network, right? It's almost a gigabit in both directions. So that's as much as this host can push if there's no other limitations in the stack. All right. What we've just seen, thinking about the article, The New Internet, we've seen a Kubernetes phone that can push 300 billion requests per month. If you remember, he's saying 500,000, 300 billion. On the right-hand side, you can see my phone. On the left-hand side, you can see my son's phone. And in the middle, for comparison for size, that's exactly how big this host looks. Why single node? Single node is very simple. Really simple. Like literally you can carry it with you, you can demo it, you can showcase it. It can be bigger, it can be smaller, doesn't really matter. It's really simple. It's efficient. It has 45 TDP. And it's portable. I could bring it here, I could show it, I could demo it. You know, it makes certain things really easy. Now, you can get some crazy fast single nodes in London, because that's where the conference is. For example, that one, 12 cores, 64 gigs of DDR4, NVMe 1 gigabit for $88 per month. You want 10 gigabit? You want more networking? That's the most expensive one you can get there, which has almost 200 cores. 200 cores, 128 gig of DDR4, the NVMe disks, 10 gigabit for 833. You can get a lot of power. Computers got crazy fast. But seriously, like single server? I mean, everyone is still stuck on that. Like, why single server? Let's see if people can recognize who wrote this tweet. A single server can go a long way these days. It's a trade-off that requires spending more time optimizing for recovery instead of high availability. Does anyone recognize this? This is a great tweet. It's in response to DHH. It's from Kelsey. Yes, you were. I know you were. Why Kubernetes? Why would you choose Kubernetes? You have a single node, like what's going on? Why not use just bash scripts? Why not just use packages? Well, the most important thing is that it is operationally mature. What does that mean? That means that it's API driven, right? You declare everything through an API. It's declarative. It's self-contained and continuously converging, right? It's something that it's requirement for step number 2. In my case, it manages itself. Everything that it needs to have, like you're basically mitigating a bunch of security risks. It's self-contained. You don't need to punch any holes through anything. It's very efficient that way. The ecosystem is massive, and if you haven't been to Landscape CNCF.io recently, there's a lot of projects there, and they're growing, and they keep improving all the time. I mean, that's an amazing feature being in this ecosystem. Also, when you need to scale out, it's very easy to do so. So let's do just that. Let's scale this Homelab into production. It's that arrow that I mentioned. So let's see what people think. Who would like us to use Hetzner? Hands up. Okay, so we have about almost 10. OneProvider.com? No one. Okay, me. And DigitalOcean C. Okay, so most hands up were for Hetzner. We can't use Hetzner because TalosCon is in London, UK, and Hetzner doesn't offer a server in London, UK. So we can't use that. We can't use OneProvider because not only we need to go from 1 node to 3 nodes, we also need a load balancer, and OneProvider doesn't offer load balancers. So that means that we will need to use DigitalOcean. First thing, we need to solve a problem. If we had the problem decompressing your file, this typically happens if the archive is corrupt or contains multiple files. It doesn't, it works. The problem in this case is that when you download a Talos image from Omni, even though it's in gzip, and it is definitely gzip file, DigitalOcean does not recognize it. So all that I have to do, I'm going to pick the right cluster. There you go, that's the production one that I want. And I can have a bunch of things that I can run. The thing which I want to run is Omni do image. And all Omni do image does, it basically downloads the file if it needs to. It gunzips it, bzips it, and then it's in the right format. We have the file in DigitalOcean. It's there, it's uploaded. We have the image. We can now use it. So one of the things which was running in my Homelab, it was Dagger. And Dagger is what we will use to get all the orchestration going. So what is Dagger? It is about automation, but automation is code. So not scripts, not YAML. You can write everything in your language of choice, whether it's Python, whether it's TypeScript, whether it's Go. That's how you declare your automation, your pipelines, and you combine them in ways that are reproducible because everything runs in containers. And it means that if it runs locally, it will run exactly the same in your CI of choice, in your CI platform of choice. Whether it's GitHub Actions, Jenkins, it's identical. All right. If you go to videogerhard.io, there's this particular video, Modern CI/CD Pipeline from Scratch, which is about 2 months ago, where we are starting to build a CI/CD pipeline in TypeScript, which will run on GitHub Actions using Dagger. So it's about an hour long, and more are coming. So if you want to see like the whole experience, what does it look like? What are the aha moments? It's all there. All right. what I'm doing here, I'm confirming that I'm connecting to an engine, which is the server that's running in my Homelab. And you can see the first command, right? So the environment variable is set. I can check that the CLI is installed, Dagger version. So I have the CLI installed, 0.13. And if I run Dagger core version, it will tell me the version of the server. I confirm at the bottom that I am indeed connecting. I'm opening a TCP connection to Dagger Homelab, which is running in my Homelab, and it's using Tailnet. And the reason why I'm doing this is because I want to make sure that all the automation which I run runs locally or runs, in this case, in the Homelab and on my host. So it's self-contained. Again, it's all local. And the command which I'm going to call is Dagger call DigitalOcean. I'm going to call the Dagger CLI. Call is the command. And in this case, I'm calling the DigitalOcean function. And everything is implemented in this function. What is in this function? There's a .dagger, it's a convention, it's main Go. And this is a module which contains multiple functions. In this case, when I'm creating the context where this is going to run, you can see that I'm picking Ubuntu 24.10. I'm installing a couple of tools, curl, bash, gettext, unzip, a couple of dependencies. I'm getting just. I'm getting a mounted directory with basically mounting my local state. I'm provisioning some secrets in a way that will not leak because they are of type secret. This is important. You can see the Argo CD GitHub token right there at the top. This is Go. Right there at the bottom, 48, 49. Let's see if I can. There you go. OmniCTL. Basically, I'm installing a bunch of things, but in a way, I'm already getting that from the local context so that it works the same locally as it will work in this container. So I'm installing OmniCTL, I'm installing kubectl, and I'm also installing kubelogin. So the context for what I'm going to run is in the right shape. The next thing which I'm going to do, and this is the whole DigitalOcean function, this is it. This is where all the logic happens. So these are the various arguments which I can provide, number of droplets, whether we're going to delete, and this is the context. The context is the DigitalOcean doctl container. That will do all the heavy lifting. So in this case, if it's a delete, you can see how I'm basically having a for loop. I'm using Go routines. I'm saying delete the load balancer in this case, or create it. And there's quite a few things that need to happen when you create a load balancer. So first of all, create the load balancer, but then also, for example, add some extra forwarding rules, and just using the doctl CLI. Also, create the droplets, create the cluster, bootstrap the cluster, and these are the two Go routines. So everything happens in parallel. There's some back off, by the way. I need to wait for the nodes to register. What else is here? Oh yes, waiting for machines. So this is what shows like before I can bootstrap the cluster, the nodes have to be in the right place. Also, I have to then template the cluster config, right? Because I have like new machine IDs, and then I create the cluster. I run the status command. And over here, oh yes, this is a fix that we need to apply for kubespan, right? Like we need to get the private IPs, and then we have to configure the nodes. We have to give annotations. So all this is to show there's a lot of stuff going on in the background that you have to think about, right? And you have to encapsulate somewhere. So would you rather write YAML? Would you rather write, like, you will end up with some sort of weird DSL to build these things. And sometimes you wish you had a programming language where you can do, for example, proper threads or proper routines, whatever the case may be. You may have, for example, a backoff library that you use, whether it's Java, whether it's Go, it doesn't really matter. So there's a lot of power that programming languages have that we tend to replicate in other ways, and that can be a bit like pushing a rock up the hill sometimes. All these concerns you'll have to address one way or the other. And the scripting that you would write that would replace this is involved. So let's see how well this works when we put it together. The first command, I'm going to store some secrets, and secrets, I could show them to you. I haven't. All they do, they're 1Password CLI invocations, which securely load the secrets, put them in my context. This is my local context, and I can use them in subsequent commands. Then I'm going to do Dagger login Gerhard, which will connect to the cloud, and we'll see what that means. And then I can see the command, the actual DigitalOcean. The reason why I'm wrapping it is because there's quite a few things which I need to provide, like quite a lot of flags, but that's all of it. That's how I can invoke a cluster, a production cluster on DigitalOcean, and make everything else come together. And there's a lot of stuff. So we're going to run this, and we're going to see what happens. Okay, so I'm going to run the same command. That was the dry run. We are connecting to the engine. We're getting all the code that needs to be in the engine, which is a server, the actual Dagger server. This hasn't run before, which means that some Go code has to be compiled, downloaded. And this is what it looks like when things are running. So what we can see here at the bottom, we can see that a bunch of operations already completed is the green checks, and other things are running. We can see the droplets were already created. That's fairly fast. We can see that we are creating the load balancer, and that will take a while, right? It's still running. There's a lot of stuff happening here. The interesting thing is, if you notice there at the bottom, there were a couple of shortcuts. I press W, which shows me the same thing in the cloud. So everything that's running locally, it's sending traces to the cloud, and I can see the function that's running as it's running, and I can see a trace view of everything that runs within it. So in this case, we can see that the load balancer was created in 43.3 seconds. We can see the exact command which ran. We're going to see, for example, the droplet only took 2 seconds to create, and this is real, by the way. That's exactly how long it takes. So droplets are quick to create. Load balancers can take a while in DigitalOcean. And then what we can see here, we are waiting for the machines to register with Omni. And we keep checking. That's where the exponential backoff comes in. So we keep waiting for the machines to appear in Omni before we can bootstrap the cluster. And that's what basically this does. We're calling the create. We're waiting the status, right? Because create sends the command. It returns very quickly. Status, you'll recognize this once you apply a cluster config, right? It has to, all the components have to be healthy before this returns. And that's what we're waiting for here. All right. If we come back locally, this is, you can see 3 minutes, just like a minute later, everything finishes. We're using the kubectl, we're using the annotations, right? We're configuring Argo CD, which then from here onwards, the cluster should be self-sufficient. It should be able to continue and finish configuring everything else. And that's it. 4 minutes and 30 seconds later, we have everything provisioned, the whole thing. Not only we created the resources in DigitalOcean, we put a load balancer, we did like all the configuration, we registered the droplets with Omni, we bootstrapped the cluster, and from this point onwards, Argo CD should finish everything else that it needs to. The 2 Go routines are important because some of these things take a while, so you want to parallelize as much as you can. But because you have code, it just makes things easier. So 1 Go routine, create the load balancer, add forwarding rules. This takes about 1.5 minutes. The other Go routine, create the droplets, wait for the machines to register, template the cluster config, right? Because you don't know what the machine IDs are going to be, so you have to wait for them to register to know what they are. Then bootstrap the cluster, wait for the cluster to finish bootstrapping. On DigitalOcean, we have to fix kubespan. There's like a little gotcha there. And then Argo CD, install it so that everything is there. So it pulls down the GitOps. We have the repository configured, so it continues. So we can see the cluster here. This is what it looks like when everything is provisioned. It's a fresh cluster. The only thing that I could do, maybe upgrade Kubernetes, but it's all here. The backup already ran, by the way, which is very nice. We have 1 control plane and we have 2 worker nodes. Provisioning more is just a matter of changing a digit. That's it. Back in the cluster, there's a problem. There's a problem with this cluster. What is the problem? Who can spot it? Who knows what the problem is? Has anyone seen this before? DNS. Yes, it's always DNS. It is DNS. So this was me the day before yesterday. I have 3 DigitalOcean droplets running Talos 176, all managed by Omni. I'm using the standard image, no extensions. The problem that I'm seeing is core DNS queries are timing out. I narrowed it down to the CNI 0 interface. The DNS queries which are hitting the core DNS pod, which is local, work. When the core DNS, by the way, because there is a service, right, queries will go to whichever core DNS instance. You can't guarantee they will always be local. Do you know that guy there at the top? I just troubleshooted this with someone recently. The problem is DigitalOcean. And again, this was yesterday. That's helpful. So I stumbled across that fix. I applied the fix. It should work. I don't know why it doesn't. I need help. So if someone has an idea or if someone, that's the thread maybe to follow. It's in the Omni Slack. So that's where we can continue this conversation. All right. The one thing which you would have seen if this finished is how this cluster, when it bootstraps with all the actual workloads, the Daggerverse itself would have restored from backup. So the idea of self-contained workloads goes beyond like install, for example, Ingress and Nginx, or like the stuff that you expect to be layer 0 or layer 1. You can also continue this philosophy to the workloads, whether maybe they have some local state that has to be replicated, whether you have, for example, Postgres that needs to do replication across clusters. All that is just more orchestration, and it's a little bit more difficult, but it is well possible. Cloud Native PG supports that. In this case, the way I have it configured, when a cluster comes up, just restore from the last snapshot. And it's all baked in. What does that look like? In this case, we can see we have the backup definition there. We're using barman. You can see bootstrap recovery says go from backup, recover from backup. Yeah, that's it. So that's how simple it is in this case to set up recovery for a stateful workload, which is using a database. So the database itself can provision itself. We couldn't benchmark the application because we couldn't get it set up because of that problem. Could we at least benchmark the production network to see what we would get in DigitalOcean on these droplets? This is running on one droplet, and I'm basically hitting the other one. I'm going over the private network. So you can see that the DigitalOcean droplets, they seem to be limited to 2 gigabits per second. And it doesn't matter how big or small the droplet is, this seems to be a limitation of the platform. I used higher and lower ones, basically as far as I could go, and I couldn't get the 2 droplets to go over 2 gigabits. What are the takeaways? This is the last part. What have we learned, or what have I learned, something that served me well, which I would like to share with you? The first thing is that hardware became incredibly powerful. Really, like in the last 5 years, it's crazy how many cores you can get and how cheap they are. All you have to do is look at your laptop. Right? Your laptops, especially for like the latest Apple Silicon, you get a lot of power. The one thing which I would say is measure it, because you may be surprised where the bottlenecks are. And they're rarely where you think they are. That's something which I've learned the hard way. The one thing which served me really well is to optimize time to recovery. So make sure that you have backups, make sure that the backups work, and exercise them. This is a prerequisite. Once you optimize for recovery, what you can do is do not do in-place upgrades for miners. It doesn't matter whether it's Talos, it doesn't matter whether it's Kubernetes, it doesn't matter whether it's Ingress and Nginx or Kubernetes stack. Whenever I've done in-place upgrades, I've always hit little issues. And it's never with the stuff that you think will fail. It's always some other component that depends on this, that you didn't realize, and stuff just breaks in subtle ways. If you start fresh every single time, you have that like new car, like fresh new car feeling, right? You go there, everything's perfect, there's no cruft, you have like a new perspective, and it forces you to double check and reassess some of the assumptions that you may have made in the old system. This is a beautiful way to take your time and go through the upgrades in a way that doesn't removes so much risk. And it doesn't matter, again, what you're upgrading. It allows you to benchmark things, to stress things, to make sure that whatever you've picked for your next generation works well together. And then you can build on top of that. Rule number 1, make it work. It doesn't matter how ugly it is. My Go code, it's not the best one that I could write. The point wasn't to write beautiful Go code. The goal was to show how all the pieces fit together, and I just did that. It didn't take me long. It was fun, I have to say. Some surprising moments, but nothing that could not be overcome in a few hours. Once you have that, once you have your first thing working, just keep improving on that. It's a great game to play because things will only get better. Right? So forget perfect, forget, we need to get in a certain place or otherwise. No, just get it working, and then from there, keep iterating. My name is Gerhard Lazu. I wear multiple hats. I've been head of infrastructure at Dagger for the last year. We run on EKS, big EKS users, big AWS users of Dagger. We run a bunch of services. This talk is recorded. You can see the cameras, and there's 2 microphones for redundancy right here. And this talk will be posted on makeitwork.gerhard.io. So if you want to see it the way I thought the talk should be, I will edit all the parts which I feel would make it better. Every 2.5 months, we keep improving the changelog.com infrastructure. We have the Kaizen episodes. Some of you may have seen them. And we've been doing this for the last 3 years. It's great fun. Went through Docker Compose. We went through Kubernetes. We are now on Flat.io. We are building a CDN. We're doing crazy things. The idea is always to keep improving little by little. And every 2.5 months, we have public discussions. We create public GitHub issues. We have pull requests. We interact with the community. Go and check it out. And because we are in a movie theater, there's no better ending screen than this. This is the end. A bunch of people watched versions of this talk and they helped me improve it. So thank you very much to all of them. And this is it. This is the end. Thank you all. If we have time for questions, I'm happy to take some.
Hi. With the performance test you were running on the 10 gig link, was that over a Tailnet connection, or was that just a pure?
No, it was pure yes. When you run Tailnet, you can expect 20 to 30% reduction in speed. Whatever the link is capable of, you'll see 20 to 30% less, because there's another process, another Go process that needs to use CPU, and it's not as efficient as using directly. The last one, which I ran 120,000 requests per second, that was going directly to a node port. Had I benchmarked it with Tailnet, it was less than 100,000, just to give you an idea of what you can expect.
You showed the traces
Yep.
when running the Dagger tasks.
Mm-hmm.
Were those actual OpenTelemetry traces? Because they would feed nicely into some of the DORA metrics.
They were, yes. The CLI and the engine, when they talk back to the cloud, they talk using OpenTelemetry. Everything is OpenTelemetry. Different OpenTelemetry backends or sinks or destinations, you won't see the same level of fidelity, right? Because OpenTelemetry is a standard, right? You can spit a lot of stuff through it, but then on the other end, you have to interpret those, right? You have to put a meaning to what you're seeing. So in the OpenTelemetry sense, for example, imagine that you have a lot of operations running in parallel, and you have to stitch them together and you have to make sense when really you're trying to model a DAG. Because what's happening in the background, you have a DAG that converges on the final state, and conveying that through OpenTelemetry is hard, which is why you could point that to Honeycomb. You could point that to Jaeger. Like you can say, this is the OpenTelemetry, the OTel backend, but you would not get the same amount of detail because we go deeper when it comes to understanding those traces.
You showed a neat debugging container. Could you give the name again?
So the debugging container, I named it sysadmin. If you pull it down from ghcr.io, it's on the GitHub container registry, /Gerhard, my first name, /sysadmin, you'll have all the tooling that it's built into it. So it is public, anyone can use it. I have btop, I love btop. I have atop, I have htop. There's a lot of tops there. There's iperf, there's like a bunch of things. There's, for example, eBPF tooling that you can use it natively. All you have to do is look at the manifest to see all the commands which are there. I haven't put it yet in a module on the Daggerverse, but I could. So that's a good shout out. The other thing which I was going to ask you before we take more questions, if someone found useful the whole DigitalOcean automation, I could put it on the Daggerverse for others to see. So if you're interested, let me know, and then I can make that happen. Vincent wanted to ask me something. I asked you lots of questions today, so if you want to ask me one, you can do, but you don't have to. You coming to the talk, I really appreciate it. Thank you very much. I wasn't sure that you would do even that. And you brought Luis as well, so there's one more question there. Ian, yes.
I'm a sucker for NUCs and Raspberry Pis and things, but I hadn't heard for the
LattePanga Sigma, yes.
The Sigma.
Yep.
So can you tell us why you use that and sell it to us if you want?
Okay. So Patrick from Serve the Home. Anyone watching Serve the Home YouTube videos? Yes, Serve the Home. So he covered it. There are a couple of other YouTubers that covered it as well. I forget their name, but I remember Patrick. And I was thinking, wow, this is cool. Let me buy one and see what I can do with it. Because where it's going, remember from that Super Micro, which by the way still runs strong, but it's just a motherboard mounted on an open bench. So I was thinking, okay, how can I get something which is more powerful, more energy efficient, but also something that's portable. That's what I was looking for. Nice and silent and portable, which I can get NVMe disks in. And that's just how I stumbled across it. The thing which I like about it, most important thing, it has an Intel GPU, an Intel Iris GPU, which means that it has video sync. So that's what I'm most excited to try out. And really, it's just like the size of a phone. So for what I needed, it worked well. I can get two. The one thing which I wish it had more of, I wish it had more storage, because I'm trying to get like as many NVMe disks as I can into it. Well, there's, you know, like when you watch movies, the thing which I love when I see there's like one more scene, right? There's the end, you see the end, there's like one more thing. So what is the one more thing? In this case, the one more thing is cleaning after yourself. All I'm doing there is basically delete the cluster, right? 1 minute, 43 seconds. This is 6 seconds. This was a bit quicker. All I did here basically is just DigitalOcean delete, which called the delete code part of the same DigitalOcean function. And that's it. That's how quickly, yes.
I have my question.
Yes. Excellent. Okay. The end again.
There is one more.
Okay.
Thank you. Did you put your OmniCTL Dagger module on the Daggerverse?
Not yet.
Oh, you should do that.
I should. Yes. Yes, I will.
That's it.
Thank you. That's a great question. Thank you, Vincent. Cool. I think that's it. Okay. Thank you very much. Thank you. Since you watched this video to the end, I know that you enjoyed it. I also think that you will enjoy the 3 conversations from this conference that I published as episode 8 on pod.gerhard.io.